Kindly.
Hey guys.
Okay, I think.
Hello, remember recording?
Yes.
Okay.
I will.
I'm recording now.
Okay, I think we can get started. Okay. Good morning and good evening to everybody. So welcome to the very first community meeting of Chaos Mesh. I think everybody who joined here may know Chaos Mesh already. If you do not know already, Chairman will, our maintainer will give a very comprehensive introduction later. So I'm Calvin, and I'm the community manager of Chaos Mesh. It is my pleasure to be your moderator of the meeting today. So before the regular session on the agenda starts, I would like everybody to have a self introduction, and so that we could know each other. So let's start with let's start with Bella, because she is on the top of the list.
Okay.
Bella, would you introduce yourself?
Okay. Hello, everyone. Nice to meet you. I'm Bella from PinCap. I'm mainly responsible for assisting Calvin with Chaos Mesh community operations. And that's all. Thanks.
Thank you. And the next is Gaosong. Hi, Gaosong.
Hello, can you hear me?
Yes.
Yes. Well, nice to meet you, everyone. I'm Gaosong, and I'm the maintainer of the Chaos Mesh. I also work in PinCap. Yeah, that's all. Thank you.
Thank you. The next one is Zhou Qiang.
Hi everyone. I'm Qiang Zhou. I'm the maintainer of the Chaos Mesh, and welcome to our first community meeting. Thank you very much.
Thank you. Next is Chairman.
Hi. Yes. Can you hear me? Yeah.
Yes.
I'm Chairman. I also the maintainer of the Chaos Mesh, and I'm from PinCap. And in this talk, I also will have an introduction about the Chaos Mesh. Yes, and that's all. Yeah.
Thanks, Chairman. Hi, Lee. Please introduce yourself.
Hey, I actually feel quite at home joining the community meeting. Well, you know, probably for a few reasons, because there's some friendly people here, but maybe the biggest one because I feel like for the first time, my name fits right into the list. I'm surprised there aren't like 5 other Lees in the list, but I feel like I was made to be on the list. So it's good to be here. It's cool to see you guys kicking off the first community meeting.
Actually, yeah, because each time you are the host of the meeting, and now you are the participant. Yeah,
I can take a break.
Yeah, take a break. Thank you for coming. Yeah. So next is Chris Huang. Hi, Chris. Can you hear us? Okay, we don't get him right now, so we may come back later to Chris. So next is Galadot. I'm not sure if I have pronounced it correctly. Hi, Galadot.
Hi.
Hi.
Hi, can you hear me?
Yes, only it's the voice is a little bit low, so you can speak up a little bit.
Okay. Hi. I'm Gerardo. I'm from the Xiaopeng Moto. Nice to meet you.
Yeah. Oh, great. Yeah. By the way, Xiaopeng Moto is one of the Chaos Mesh adopters. So Galladot is also our contributor. So thank you for coming. And next is Ming. Ming, please
Hi.
introduce yourself.
You
Hi.
hear me?
Yes.
Hi, I'm Ming, and my name is Wang Ming, and I'm now a software engineer in CMB China. That's China Merchants Bank.
Oh.
Yeah.
Right.
And I'm now a collaborator of PinCap Chaos Mesh, and working at stress chaos for.
Oh yeah. Great.
Yes.
Yeah. Because stress chaos is a very recent feature we just spotted. So thanks, Ming. Yeah.
I think it's still have a long way to launch for the
production use, right?
Steady or more neutral one to.
Yeah, sure.
To the adopters, yes.
Yeah, I see.
And I hope to improve that together to get the work at production.
Yeah, it's really great. Thank you.
Thank you. Okay.
Yeah. So the next is Naveen.
Hi everyone, I am Naveen. I am from Layer 5. I am a contributor to Layer 5 and I have contributed to Meshly SQL adaptation.
Hi Naveen, your voice is kind of low.
Hello. Sorry. Is it clear now?
Yeah, much better. Thank you.
Yeah. So hi everyone, I'm Naveen. I am a contributor at Layer 5, and I am primarily more contributing to Istio Service Mesh.
Well,
adapter of Layer 5 of Meshly.
Cool. Thank you for coming. Yeah. The next is at 15.
Hi, I'm Ping Lei at 15 is just my GitHub handler, I guess. I suppose people can hear me, right?
Yes.
And I previously worked at Google, and I have contributed to Chaos Mesh a bit, and that's it.
Cool. Thank you. Yeah. Next is Yan Yichen. Yichen, please.
Yeah. Hi, I'm Yichen, and I have contributed to Chaos Mesh recently, and I'm still working on my master's program, so not working yet. Yeah.
That's great.
Thank you. That's all. Yeah.
Thank you. Yeah. And we have a last attendee here, Zhao Kun.
Hello, everybody. I'm now a master student come from East China Normal University and the specialization in data science and engineering. Recently, I'm a user of Chaos Mesh, and I want to learn how to use Chaos Mesh effectively. And I'm very interested in Chaos Mesh. So, if I have a chance, I hope I can make the contribution to Chaos Mesh. So I attend this meeting. Thank you.
Yeah, that's really great. Yeah, and I hopefully I believe that you can get something from this meeting, especially from the presentation by Chairman later. Yeah, I'm really glad that to see so many folks from the community joining this very first meeting. So as the community manager, and I'm really glad. So so let's look at our sessions today. Actually, we have very short agenda because as the first meeting, we just want everybody to know each other, and so now we just finished that, and the next thing is our community sharing. So for the chairman will provide a kind of comprehensive or introduction to Chaos Mesh. As some of you may already know that we've just presented to CNCF like two weeks ago, and this presentation was based on that one, but it's more comprehensive and more focused on the technical aspects of it. So, Chairman, I will leave the stage to you.
Oh, okay. Okay, yes, I will share my screen. Okay.
Okay,
new Lofty return. Yes, I will share my screen. Hi, yes, can you see my screen?
Not yet, but I think it's on. Yes.
Oh, okay. Wait.
So I think Lee is familiar with this.
Yeah, no, looks good. I could see the screen though. So.
Wait a moment. Yes. And here, yes. Okay. And can you hear me? My network is not stable, so I must make sure can you hear me, and my voice is clear.
Okay, cool.
Okay. Hi everyone. I'm Chen Wen, the maintainer of the Chaos Mesh. I'm from PinCab, and I also work on TDB project, which is a distributed NoSQL database. Today, I'm very glad and here to make an introduction of the Chaos Mesh in this very first community meeting. In this talk, I will show you how why we need Chaos Mesh and how we design and implement it. And last, I will show a quick demo and also introduce some future works. Without further ado, let's begin. Yes. Let's start with some background of the Chaos Mesh. In 2017, I joined the PinCab, and at the same time, I started to do some work related to chaos engineering. Yes, yes. We build internal chaos testing platforms, and we call it Schrödinger. And here is Schrödinger the logo. But this platform is designed for TDB and totally coupled to TDB code. As TDB group, we have more and more ecosystem tools like TDB, binlog, and so on. And also we need to test these tools and support these tools in our platform. As you know, the process is very terrible, and yes. And last, we realized that we need a universal chaos testing platforms, not just for TDB, but also for other distributed systems. So, and here we saw the potential of this project and decide to extend the chaos engineering part into a more general project, which is Chaos Mesh. We start this work and September of last year, and also we open sourced it and by the end of the last year. So far, we have migrated all chaos experiment of the TDB and the TechUI to Chaos Mesh. Yes. Yes, let's get into some details of the why we need chaos mesh. A big challenge on Kubernetes and containers is itself. For example, in PinCap, we have our internal testing platform environment is all on a large Kubernetes cluster, and we have different types of tests and different versions of our database. Yes, so like this, which means we will have so many chaos experiment in a super large Kubernetes clusters. For example, and here we will have many TDP clusters and many surveys. And here we will so many chaos experiment such as QD. PD is the another takeaway is the components of the TDP cluster. And here we will also need to simulate the network partition, network delay, and so on. Yes, if we want to measure and schedule this so many chaos experiment by hand, it is a very terrible. Yes. Yes. What's even worse? Some tools don't work well inside the containers, like the TC, Habitables, Fuse, and BCC. And these tools, we can't use them in container directly. Yes. In addition, if we want to inject some failure in containers, we must make sure the other containers on the same physical node, can't be affected by this action. Yes. So we need chaos mesh to free us from this boring and dirty work. And because I'm very lazy, yes, I'm so lazy. And the next is when we design a chaos mesh, we send 3 principles. And the first one, I think this is the most important. I think we want our chaos mesh must be easier to use. We want the new users can run their first chaos experiment in 10 minutes. The second principle is scalable. Yes, we require chaos mesh must be easier to integrate with the other testing frameworks. We have many other testing frameworks for different systems. Yes, so we want chaos mesh to be leveraged either and directly by these frameworks. The last principle is we want the chaos mesh must be designed for Kubernetes, because we believe the Kubernetes is the future operation system on the cloud. Yes, okay. Then I will talk about some key features and technical design of the chaos mesh. The first thing is clonative. And here we use the CRD to define different kind of the failures, and so the developers and the QA engineers can use YAML fields to define the chaos experiment. We also use the sidecar to help us inject the failure to application pods. So it is totally transparent to the application layer. Yes. In addition, we also provide many different kind of chaos types. For example, we provide the network chaos, and we provide the network delay, lost the network partition, and we also provide to simulate some different kind of chaos. And here, we also can inject the file system errors and very cool feature is the time chaos. Yes, and which simulate the clock skew. Another intuitive feature is a kernel injection. Yes, I will introduce more details about them later. Yes, the next. This is the architecture of the chaos mesh. Just like I said earlier, we can see in the picture. It is very cloud native. We use the CRD. Yes, we use CRD to define the chaos experiment. Yes, we also use a sidecar to inject some specific failure. For example, we use the field service as a sidecar to help us simulate some field system failures. Yes, and here I will introduce about our chaos more detail in the following slide. We also create a customized controller manager to manage the chaos experiment. I think this component is the brand of the whole chaos mesh. Yes. Yes. We also have a component called chaos daemon. This component run as a privileged daemon set, and yes, to operate the network device on the node, C groups, and others. This component will deploy on each Kubernetes node. Yes. This component is important, very important, because our many injection ability are provided by this, such as the network failures, cross skills, and stress chaos, and so on. From this picture, we can see that the architecture of the chaos mesh is very straightforward. Yes. Yes. On this picture, I will show how these components work together. And here, I will use the TDB cluster as the target application and inject the network failure in this application. First, we need YAML fields. We need to use a YAML field or use a Kubernetes client to define a chaos experiment. Yes, in this experiment, we need to define the scope of the chaos. And here the scope is takeaway. Yes, we also need to define the chaos action, and here is a network failure. Yes, a network delay. In addition, we also can use the cron job to schedule our chaos experiment. Yes. The first step, we will apply the YAML field to the Kubernetes API server, and then the controller manager will receive the creating event and then send the injection requirement to the health daemon or sidecar container. Yes, yes. In the end, the chaos action are executed by the chaos daemon and take effect on the application containers. In addition, if we want to use the sidecar containers, we need to set the specific labels on the application namespace. This is because, and here, we need to use the admission webhook to monitor this namespace and yes, and inject the sidecar into the application pod when we create the applications. Yes, 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 yeah. We use the and here we use the different CRDs to implement different chaos. And now let me introduce more detail about how different chaos work. And yes, I will only cover 3 of them because we have so many. The first one is network chaos. Yes, and here and we can use the network chaos to simulate the network failures. I think it is very useful for distributed system. From this flowchart, we can see we need chaos daemon to help us. And here, I just introduced the basic logic about this chaos. We will send the requirement to the chaos daemon. The chaos daemon will enter the network namespace of the pod and to send the IP set or change the IP tables or other operate other network device like network interface. And then yes. The second is our chaos. Yes, I think it is a very cool feature and because it is used for some storage systems such as TKV, EDC, and so on. As we know, simulating the field system failure is very difficult. So, and here we introduce fields in our chaos to help us. Fields is a field system in user span, and many users use fields to build their own field system. Yes, and we also here we also build our field service and use field service as a sidecar and will ingest the field service to the application pods. Yes, and then we will use a field mount to mount the application's data directory in sidecar container, and then we will start application containers. And this time, if we do some write or read operation on our applications, our operations will be hijacked by the field service. In this way, we can inject our latency or our errors to the application. Yes. 1 month ago, we implement the time chaos in chaos mesh, and it is a very cool feature. Yes, nowadays some distributed systems are highly dependent on timestamp. So clock skill injection could find a deeply hidden issue. But in containers, we can't modify the dead time directly because this action will offend the entire physical node. To avoid these problems, we use a very hack way to implement the time chaos. Yes, and here we also use the chaos daemon and also set the injection requirement to the chaos daemon. The chaos daemon will write a fake function into the process memory. This process is the target application. Yes, and then the chaos daemon will modify the clock gate time in the process VDSO. Yes, and the clock gate time is a system call and stored in process VDSO. And yes, we'll make it redirect to the injected fake function. Yes, and here I just introduced a basic logic about this. If you are interested and want to more details, we just publish a blog article about it. If you want to more detail, you can click this to get the details. Yes, and in addition, in the next meeting, the author of this feature also will have a talk about it. Yes. Yes. Okay. enough about the technical details, and now is demo time. In this demo, I will show how to use Chaos Mesh, and I will run an application called Web Show. It's just a normal web application, yes. And I will use this Chaos experiment, and here is this as network chaos, and we define the chaos action is a network delay, and the latency is 10 milliseconds. Yes, we also use the selector to define the scope of our chaos, and we use the scheduler to define to schedule our chaos experiment. Which means is we will inject the network failure every 20 seconds, and the failure will last 10 seconds. Yes. Yes. Okay. To same time, I have deployed the Chaos Mesh in my environment. And here, you also can find the example in our Chaos Mesh repo. I will deploy the Web Show application. Yes, you can, and here find this example. Yes, you can hear. Wait a moment. Yes, the Web Show application is started. We can okay. Yes. The application is running, and here the Web Show application will record the network latency from this pod to the Kubernetes system pod. And here the latency is around 1 millisecond or 2 milliseconds. Yes. I will apply the chaos and the network failure to this application. Yes, it is. Our chaos mesh is very easy to use, and we just will run command to apply this application. We will apply. Yes. This chaos experiment has started. You can check the result from the web page. And yes, and here the network delay has injected to the application, and this the latency will last 10 seconds. And here, if we want to delete this chaos experiment, we just need to delete. Yes, one moment. We can see our network failure can delete from this application. Yes. This is just easier demo. If you want to try the other failures, other features, you can run chaos mesh in your environment according to our document. Yes, let us return to our talk. Yes, and last, I will introduce some future works. As you know, chaos mesh is very young compared to other chaos tools. We have many work need to complete. Currently, I think chaos mesh is not friendly to observe the chaos without. It's friendly for some users who don't know chaos mesh, who don't know Kubernetes. I think a dashboard can help them. Yes, this is also what we are doing, and we will include this these features in the next release. In addition, we are considering making a public service on public cloud, like GKE or ETS. So it is more convenient for users running their service on GKE or ETS. You can just claim some buttons on our service and start chaos experiment on your applications. Yes. The third thing is about automatic validation. What is automatic validation? Yes, when you inject the chaos in your application, you need to check the output of the application and check if your system going well. And we have already implements automatic validation on our database, but it's not suitable for other systems because we don't know how to check your system behaviors when you inject your chaos experiments. So we plan to create a universal verifier API layer. So then the developers can develop their own validations for the system. So the whole test process can become completely automated. Yes. Okay. My talk is ended. Any question? Yes.
Okay.
Any question?
Thanks, Chairman. So if you have any questions, this is the time because all our maintainers are here. So
yes.
Yeah.
Yes, I will stop sharing my screen. Okay.
Okay. So does anyone has any questions? Lee, do you have any questions?
You know, for me, for the most part, well, how should I say? So great presentation. You know, good to see you guys have some, I guess I would say, unique experiments. You know, to this project as versus others, which is nice. To me, what's really I think telling about how intriguing a given chaos system are probably about some of its core components. Core components being that of scheduling, that of facilitating workflow, if you will, being something of a workflow engine. You could imagine wanting to string together a few different experiments in a row, like facilitating standard reporting of results, such that when you know, a given experiment runs, that you're going to want to take a look at, you know, a few different things, maybe some logs that were collected, some metrics that were collected. Maybe you want that formatted in a particular way that you can get a report, you know, because maybe these are things that you're scheduling. So I'm going to come back and look at that report later. That type of those framework things, scheduling and you guys have got a number of them, I think, in this project about how you're sidecarring things, how you've got chaos daemons, how you've got the framework for admission webhooks, you know, how it is that you can initialize these experiments in a Kubernetes native way through CRDs, all very good building blocks. The ability to, I'm not sure how much more fancy the scheduling needs to be, you know, as you guys are using cron today. In some respects, that's nice because cron has been around for a long time and people generally understand, you know, how to schedule things through cron. But I can imagine some use cases where people want to, where a bit more focus on the scheduler, being able to kick off. I think in here, did you guys say that you have the ability to invoke experiments based on an event occurring? So not time-based, but based on an event?
Chairman, do we have that? We have a schedule based on the event.
Yes, we record the event in our communities, and also we will store this event into our dashboard. Yes. I think and present the event of the communities is not very clear and present, and I will and we will improve this. Yes. I don't sure your question is about this.
That does answer some of them. In part, I was haranguing you guys on some of the things that, as I look at the project from the perspective of being a potential robust user or being a potential integrator with Chaos Mesh, that there are some important things about a Chaos project. And in some respects, for me, it's lesser about the specific types of experiments that are available, because if it's going to be a successful project, there will be lots of different types. I say experiments, but maybe I should say chaos. There will be lots of different types of chaos that will be built and come forth, and there will be a library of chaos, and that's awesome. I think that you'll end up with a library of chaos based on having a decent SDK, if you will, or a decent framework in which people can create new chaos. You'll be successful if you have a robust scheduler that you can, ad hoc invoke chaos just as and when you want to through a CRD. Perfect. You can invoke chaos through a time-based schedule. That's great. And the more robust that is, the better. To the extent that you can also invoke chaos maybe based on an event or as part of a CI pipeline or something. I mean, that could be event-based, or that could just be, ad hoc invocation through the CI pipeline. And then a reporting framework, so essentially, like if someone's writing a custom piece of chaos and they're collecting some information about what happened in that experiment, no doubt you guys are already showing that you're capable of displaying metrics that were tracked while the chaos was running.
Yes. Your means is the CR pipeline. Yes. We also can use this chaos in CR pipeline, and I think it's good advice. And we also have testing frameworks. Use the Argo. Yes. In this testing framework, we use the Chaos Mesh and use the Argo to schedule this our chaos, and also the scheduler in our chaos is not necessary. You can use it. You can also schedule. Yes.
Yeah, that's nice. One last comment from me. I don't mean to hog the, but I guess my question is, Is there a mechanism that Chaos Mesh has to facilitate reporting, like sort of the results of the experiment?
Oh, yes. Your means is how to report the chaos result?
Yeah.
Oh, yes, yes. And here we just we will record the result in a event in the communities, and also we will record the result in the status fields in the this object, and also we will in the next release we will record the result in our dashboard, and also in here we also have metrics to record this event, and as I think in the next release we will have the better result output in here. Yes. Okay.
Nice. Awesome.
Yes. Yes. I think and present we record the event in the communities. I also I think we will also record this event to the our chaos dashboard and show it in our dashboard.
Yeah. So Lee, does that answer your question?
That's great. That's great.
So yeah, so we have it seems we have a lot to expect from our version of 1.0 release. Yeah. So as I already as I talked to you the other day, maybe when the version comes out, we hope to I mean do another demo either in our community meeting or in your in the Mercury community meeting. Yeah,
that'd be great.
Yeah. Yes. Okay. Cool. So do we have any other questions from anybody else?
Someone hands up. Yes.
Okay. So
HT.
You mean who?
HT Kelvin.
HT.
Yeah.
HT. Who is? Okay.
Okay.
Oh yeah. Hi, Hong Tran. Yeah. Maybe I don't know when you're coming in, so maybe you can give a quick introduction about yourself and say hi to everybody. Hi, yeah. HT. I'm not sure how to pronounce your name correctly. I'm sorry if I did it wrong. Hong Tran. I'm sorry. Okay. I see your. Okay. Okay, Lee is leaving. Okay. Thanks, Lee.
Okay. Bye-bye.
Okay.
Okay. I remember.
Hello.
Hi.
Hi.
I have a question.
Yeah, sure.
Yes.
Yeah, and I think if we want to perform a chaos, inject chaos into a targeted distributed system, we want to observe it. What happens in our what happens in the distributed system, and how do we how do we define this results or the experiments
Yes,
I
yes.
want to express a thing too, is that could we provide a way to define a friendly format to define E2E distributed system tests or chaos or something happened during the chaos injected by the chaos mesh. Do we did you guys understand me?
Yes, your means is how to observe the chaos result. One question is yes.
Yeah.
I answer this. Yes. If we
Hello?
inject.
Hello. Can you let me answer this question because I think lots about of this question.
Yes.
Okay. So hello, can you hear me? I'm Song Gao, and I'm the maintainer of Chaos Mesh, and I would like to answer this question for you. So in your word, I guess there are two questions from your words. The first of your question is how the Chaos Mesh users could observe the results when he finished Chaos Mesh. When he finished the Chaos Mesh, how the user to know the Chaos Mesh results. For example, if he create a network chaos, maybe he wants to know what affected of his system, affected his system, and luckily I discussed about this question from the community user for one time in a online meeting, and we get a conclusion that to better use the Chaos Mesh better, the target distribute system and the Chaos Mesh system are both needed to have a observe system, to have observability like Prometheus or Grafana. So if we created a network chaos, the target distribute system should provide some metrics like API duration or the error rate or the API response error rate, and the Chaos Mesh system would provide the target network chaos, the affected range of the target network chaos, and the user would compare the two results and would compare the results from both systems. If he find the network chaos affect a range of instances, and these instances also provide metrics that the API duration or error rate seems uprise. So the network chaos is worked well. So did you get my?
Yeah. I think
yes.
that's a way, but
yes.
However, users have to write their code to compare
the difference between the chaos injected and injected and before. I think we could provide a framework to do these things for the QA or the software or the engineers.
Yes, I answer this question. Yes, we will we will record the matrix out of the event about the which node will be inject the network failure, and we'll record this and in our customate. And yes, and also your miss is we will the validation. Your miss is the validation, and we plan to provide the validation, and we plan to do this work in the in the future. But it's yes, and we also need to do this. And yes, your advice is very good, and we also need to do it. Yeah.
Yes. Okay. Thank you.
And I think for your second question, did you mean the chaos mesh should provide us something like robustness standard for the distributed system, as the chaos mesh provides us a lot of single chaos mesh, but not chaos mesh groups that would provide your system is robust.
Yeah.
Right. I think this is quite. I think this is quite hard for us to provide this. And maybe we could provide a chaos mesh plan for the distributed database, because PingCap provide a distributed. PingCaps have a lot of experience on it.
Yes, and here we plan just to provide a universal validation API, not provide the details and how to verify. This is need to implement by the developers. We just provide the universal API. Yes.
You mean the verified API is a way for the developer to validate what happens after the chaos was injected?
Yes.
I think that's solved.
Yes,
I think that's solved.
Yes.
Yes.
We just provide the universal and last in my slide, and we don't know how to verify your system, and this is
it's business related, and it's coherent with the targeted distributed system and the aspects of your testing.
Yes. I think the automatic validation is important in chaos engineering. I think, and this is make the chaos engineering completely automatic. Yeah.
Yeah, I think the matrix collection and the status collection after the chaos was injected, that was a general question or a general method to I think that could be a general solution for a function to the developers could use this to validate their system is working or fail,
or something other or other things?
Yes, you means we need to observe the metrics of the applications and compare them. Yeah.
Yes. Yes.
Yes. But in this
However,
will yes.
However, I think it's not. It's just a thought, not not fully considered all option.
Okay,
Yes.
okay.
Yes.
Thank you. I think I want to interrupt here because we have discussed about this question for a very long time. So, and other people are waiting. So maybe
yes.
we can discuss this offline on on the Slack or somewhere
Okay.
else. Yes.
Okay.
Yeah. Thank you.
Yeah.
And on the chat box, Galadot is asking when can we release with 1.0 because they need dashboard really badly. So, Zhou Qiang, can you answer this question? When can we release 1.0?
About
okay.
the last in this corner.
Yes, in this quarter, about 1 or 2 months later. Yes, this quarter we will release the first release. Yes, the second release. Yes.
The second release. Yeah.
Yes.
Cool.
Yes.
Yeah. 2 months for 1.0.
Yes.
Yeah.
I think we maybe release 0.9 in one most and the two most we will release we maybe release the 1 point to release. Yes.
Okay. Okay. Cool. Do we have any other questions? Because we already it's already 1 hour. Yeah.
I remember a question from the Slack. Someone want to discuss about the network health. Yes. Yes,
Is he here?
I don't know.
If yeah. Turan is answering in the chat box. If you can look at it, it says the TC filter support is really useful. So is there any plan to support multiple clouds?
Oh, yes, I think it is very useful. I think we can also support this. Yes, but and this time we need to refine the network health. It will be we will have a lot of work to do this. Yes, and here I think if you want to these few features, you can provide a proposal for this, and we can divide this this work into many little works, and let community developers join this to implement this. And yeah. I think this is good features. Yes, I think we can do it. But maybe in next release. No. We maybe do it in the letter for the or you want to do it, you can help us. Yes.
Yeah. So I think we can leave the question there for the we can wait for the proposal, and we can talk about implementation in later. Yeah.
Yes. And do you think we can start with the same name team partition first? Yes, and here, I think we can use a different way also. And here, maybe I don't sure about this. Maybe I need to do some research about this and make sure which one is good for it and which one is better. I think I will answer your question in the in the following steps, not this and here, because I do not sure this. Yes.
Yeah, I think thanks Turan for your questions. I think maybe I think for next meeting for future meetings, if the question is very technical, you can just you can leave the questions in the meeting notes. I mean, before the meeting, so that the maintainers or other attendees, when they look at the questions earlier, they could think about it and maybe have a better answer to it.
Yes, I also the program question. Here is we can need to expand the IP set. I think it is okay, but yes, I think it is okay. Maybe we need more target. We need to define the map target and not only one target. Yes. Yeah. Well, I will answer your question in the following day. I don't make sure about this. Yeah.
Okay. Thanks. Thanks for all the questions. I think it's long enough, but I think we really appreciate for your attendance and the questions. I think it's very good and successful first meeting. So I guess it's very late for I'm not so sure for other people, but for a lot of folks from here from China, it's really late. So maybe we can talk about other things on Slack. We have leave this. If you are not in the Slack, you can join us. The Slack is here, and you can look at other documents and even blog articles in our repo. So I guess I'm gonna call it a day for now. So thank you all for attending our meeting, and we will see you in the next month in May.
Okay.
Thank you very much. Thank you all.
Thank you.
And also we will one more thing, we will send out the a questionnaire. Yeah, and we really hope that you could provide some feedback so that we can make this meeting better, because it's our first time. So there's maybe there must be something that is not so good about it. Yeah, but we would really appreciate if you can help us improve it. Thank you. Okay.
Thank you, everyone.
Okay, thank you very much. Bye-bye.
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 Bye-bye.